Oops. Yeah, man. My overlay thing is real janky, man. You know, I gotta get something better than this, but you see how it's skipping and everything? I hate that. So I was working on that before I started, which is why we had to delay. But we are carrying on. Last time we did the Kaggle competition. We are working on imputing values. We got a little stuck last time, so hopefully we're gonna have some better results today. Let's see if it actually went live. I had to cut it off last time because Streamlabs be acting kind of funny sometimes. So okay, I think it went live this time. Yeah, it went live. I don't know. It'd be acting real funny. Open it up. Okay. Yeah. So last time we left off, we was hiccuping through just even, you know, uploading the data set to everything. I mean, it was pretty much persona non grata. Is that the right thing? Whatever. But we couldn't even get the data set and pass that out right, so I had to change up some things. I'm actually gonna be going by a full-on tutorial this time. Once I get the tutorial up and ready, then I'll be able to actually start applying better models and experimenting and testing. I mean, this is part of data science. Like there's times you're just gonna have to start all over again. It is what it is. All right, so let's go ahead and get started. Okay. Let's see how much of our RAM is gonna be working with us today. Now I already started it, so it's well, first let's change this. Let's change that. I just noticed that we had the wrong date. All this stuff should be set already. As you can tell, I was kind of working with going crazy. But there's a Kaggle notebook. It's called Intro to Imputation. I put it in the description. The link is in the description. It basically goes through what imputation actually is. For those who don't know, I already said it. Imputation is pretty much where you're replacing values with other ones. In this case, it's missing values. And we substitute those values for whatever we want. Sometimes we substitute them with a 1, or in this case, we're going to substitute them with a predicted value inside the actual data set. So it's gonna be a crazy number in there. This data set, I'm actually just gonna kind of read a little bit from this. It's actually really good. You should go check it out. But why is imputation important? It's incompatible with most of the Python libraries used in machine learning. Yeah, it's basically, it goes along the lines I always say, like you can't use one model for the same data sets. So you have to, you know what I'm saying, try to address imputation in a case-by-case situation. It distorts the data set. You could have duplicates. You could have all types of stuff. It can make the data set be very inaccurate. And then, of course, it affects the final model, right? So the missing data can cause a bias in the data set and can lead to a faulty analysis by the model. Now, we're going to start all over again. And you know what? I am just going to I'm trying to figure out, do I even need these functions? But for right now, I'm not really going to worry about it too much. I want to see how fast it's running. Okay, that's fine. Alright, so let's get some of these import statements. Whatever we don't have, OS, Seaborn, Matplot, Type warnings, JSON, random, sys. We got our Discord open too. If anyone's in the Discord rooms, I don't think anyone's in there, but I'm gonna keep it open while we go through the thing. I found out you can actually watch video. I don't know if you can stream what I want, but you can actually watch videos on Discord. But yeah, pandas. We don't need this. You know what? So let's go ahead and leave that. Open. Okay. I don't think we're. Is there anything else? OS Seaborn. Plot. Okay, so we got our import statements. All right, I got those in. So for here, we're gonna say for directory name, file names. It's basically tracing it, the path. For file names, print the path, yeah, and join it. Which one is ignore? Why not? I don't think I have Kaggle input, but let's see. I wonder, is it gonna put that in the content folder? Okay. Kaggle / input. Okay. Alright, so we getting our submission again. Sample submission. Do I have a sample submission? I don't think there is a sample submission. Let's go back to the original. I gotta go back to the original. So what I'm trying to do is, again, getting started with another, that's May, it's June, another notebook that I think would be useful. Oh man, I didn't mean to do that because I got rid of that mean imputation. I wanted to use that too, but I'll go back to it in a minute. This guide I got is a lot better than what I was using. There is a sample submissions. Oh, this is what his, man, I cannot believe this whole damn time. Do I have sample submissions? I need to check and see if I actually have sample submissions. This is what's been messing me up this whole time. There's supposed to be a CSV called sample_submissions.csv. I do not have it. And this is what I've been looking for this whole time. Oh, man. Oh, I should have known that, but now I know. I really need to create a data set folder. I'm gonna forget. You know what? Let's do that. Let's do that right now. So that way I'm not going to keep saying I need to create a data set folder. I need to create a data set folder. Yes, June 2022. This whole time I've been like, what the hell is sample? That's CSV. Now I see it. Damn. Well, the good thing is, because I'm still gonna use this one right here, but it makes a lot more sense. Like, y'all will see what I'm talking about when I really go through it. What is this? No, not this. I want to go back to the mean imputation, because that really is like kind of the first step. Let's go ahead and zip this right quick. I ain't gonna do it. Normally, I would just do it through Python, but I just save some code and a little bit of time. I just do it right here. It takes much faster. And as a matter of fact, let me get that. That original data set. I'm gonna put that next to the I don't think you all can see what I'm doing, right? I'm trying to look at the screen, see if you all can see. Okay, you all can. Yeah. You all can see to get started with that. Okay. You all can see to get. Yeah. Okay. All right. Now this makes a lot more sense. Now I got this. All right. So Kaggle input tabular series. It needs to be someplace else. Okay. Here's what I'm gonna do. Here's because I don't want to get stuck on one thing. I'm going to try this method from the tutorial first, because I'm gonna get distracted if I do it, and I'll never complete this portion. So really quick. Okay. We need data.csv. Let's just create a little data frame right here. Kaggle input, playground series, June 22, data.csv. Now that doesn't exist, does it? No. No such file or directory. Of course. Alright. I think we can actually create one. File names in let's just say content. I'm want to save it in, because I think it's just an error of we're pointing it in the right direction. So content. Okay, let's try with just content. There it is. That's what's supposed to happen. That's why when I was starting it, like, it's gonna go through all these, but I don't really need it to do all that shit. So let's go ahead and stop it. And we only wanted to do content. And that'll be it. Kaggle.input. You know what I want it to be? I want it to be its location on my drive folder. I'm going too far down. I know it just seems like all we ever do is have errors. It's like nothing ever, it seems like it never gets accomplished, but we are making progress. Alright, notebooks. Damn, I already got one that says has for data sets, but okay, that's fine, that's fine. Okay. Should be a couple of files in there. Okay, so we want this one right here. Hello? Hey. Yeah, you caught me like right in the middle of my podcast that I'm filming right now. Okay, really quick, can you I'm gonna call you back. How late you gonna be up? Cause I'm filming. Say it again. Oh wow. Damn. Well, okay. Well, damn, you got. It's actually a tutorial type thing. You're live in front of a bunch of people right now, but. How about this? I'll just text you when I'm done. I should be done maybe 45 minutes to an hour. If you're not still up, you know, yeah. Well, I mean, I'll call you tomorrow. What time you gonna be free? Yeah. Cause I work tomorrow, but and I got practice after. So I'll be able to call. All right. Can I call you during the day then? By the way, what's your name? Elodie. Like melody. Okay. All right, Elodie. For everyone who if they're paying attention, I'm talking on the phone to this beautiful Haitian girl. Okay. All right. Bye. Damn, I didn't realize. See, y'all gotta stop the elevator engineer, man. Goddamn. Sorry. I'm trying to teach. You know how I do. Oh my god. Sorry about that, engineering fam. You know, part of the process. Jeez. Oh my god. Oh my god. Okay. Yeah. You know, yeah, elevated engineer got his knees now. He got his knees. So what's saying? All right. So it shows all the files. Sample submission. CSV and data should also be in there. So let's put data in there. I don't remember closing it, but okay. Hey, that's okay. All right. Let's go one more time. I think it's 565. Yeah. All right. So we're bringing this over. We're bringing over data. We're putting in sample submission, and we're putting them both in the same. For I need to actually save these to my local root directory, but I tend to save a lot of stuff in Google Drive because I'm always using Colab and it's easy to access remotely. All right. Right now we are bringing it over. All right. Let's extract it. Okay, we are extracting, we're extracting. By the way, like, share, and subscribe, engineering fam. You know I appreciate it. Well, subscribe if you like what I'm doing. Leave some comments. Let me know some tips. Let me know if you guys like this type of stuff. I mean, I can look at the algorithm and tell you all like this type of stuff. But, yeah, let me know, engineering fam. You know, I definitely do appreciate any type of love that I can get. Comment. One day you know what? After I finish probably this pandas thing, I want to do a little. I did a chatbot thing before, a video on that, but I want to do one for Streamlabs. You know what? I'm gonna do a tutorial on it and I'm gonna use it because I want a chatbot to promote different things. And to act as my troll away. Okay. Are we good? No, really. Are we good? Almost done. Data's bigger than submission, obviously, so data's taking a little while to unzip. Come on. Come on, you little bastard. You know, how old is it? What is it? 2022. My 5-year-old Mac is definitely starting to show its age, but you know. All right, so let's run this again. There should be 4 folders in there this time, or 4 files in there. It should be the data CSV. Oh, you know what? I gotta wait for it to sync first. I'm telling you, man, When you're in the cloud, you gotta wait for this to sync, that to sync, that to sync, that to sync. Oh God. Okay. We are almost done. We're almost done. About 85% there. The waiting game. Alrighty then. And we're walking. All right. So just sync. Let's see if we get our last file. Python sees it. All right. Got all our files in there. Alrighty then. It's not going to be Kaggle input this time. It's going to be. This is our location. Okay. All right. It's terrible stuff, but gotta put data.csv. CSV. What's wrong now? Oh, no such file or directory. But there is though. Oh, that's why. Let's go. Let's go. Let's go. I'm on my I'm on my cool teacher outfit. Hey kids, I'm cool. My shirt's open and my button up's open. I'm wearing jeans. I'm cool. Kids look at you like, listen, old man, you're not cool. Your time is finished. Okay. All right. Now, finally, we can actually get our submission file the same. Actually, as a matter of fact, sample submission. Here's what I'm gonna do. I'm gonna just copy that. Can I just? Ah, damn. Yeah. Yeah. Okay. So that won't be. It will be some. I think it's a submission dot CSV. All right. So now we're getting our submission. .csv. Really, our submission .csv. Think of it as like our target. Like we're gonna use a data set and then we're gonna spit the values into submission. And submission is only gonna have like 2 columns, I think. No, not df1. Oh God. It should be submission. I'm sorry. Yeah. Good thing I didn't go through. Hold on, let's go ahead and submission. Let's try it. Nope. No says file directory. There's no submission .csv in that location. Submission. Oh, it's sample submission. One more time. One more time. All right, that worked. You can't believe I spent the whole day trying to figure out like where the hell is the submission, the sample submission CSV. I'm looking for it, going crazy. All right. All right, so now we're gonna get into a little bit of data exploration. See, what you'll also notice too is you can't just copy and paste. You can't just copy and paste. Yeah, I'm gonna copy and paste probably 60% of all the code. But, you know, I'm not gonna just be copy and pasting though, because you can't do that. I mean, I would source it if I would, but still, because again, every problem is gonna be unique to itself. So, you know, we going through the steps. I think I'm gonna come up with like concrete steps before you even start, like, you know, like the entire data science model, like well, ETL, that's data engineering, but you know, data uploading it, doing EDA, a lot of EDA, figuring out if you're gonna even need machine learning or AI or whatever. Then you get into like, okay, I do need it. You get to normalization, etc., etc. Then you start applying your models and experimenting, pretty much, and then you score the accuracy. That's pretty much it. All right. So now we are going to print the rows, the columns, and we're gonna put the missing values. We're gonna get to some of those of the null values again. Let's say values equals 100. Jeez. Yeah. No duplicates though, so that's good. And 81 columns. So we're printing. The first column, second column is the sum. So okay, so we're getting the total amount of rows, total amount of columns, total amount of null or missing values, and the total duplicates. Oh, this is a nice way. I like the way this is formatted. Like, this is a good way to format it because it's like it pretty much, you don't have to put different what's the word I'm looking for? Like different like ways. They put it all in one line, and then he used the format function right there to put it all together in like 2 different lines. I like that. Hey Alonzo, he's a ruthless Vato, Holmes. I like that. Sorry, I apologize. I apologize. All right, so we're gonna bring in another import statement. Missing no. Oh, so there's actually a missing no import statement. It's gonna take 500 samples from DF. And it might create a confusion matrix off of it. I've never used this before. This is what I'm saying. Just says a matrix. Looks like some signals. I can't really read that. I don't know what that says, but okay. Oh, that's like the missing values. And they probably took a section out. This whole blank section right here is either what they took out or what is just null. And it formatted. We'll see, because it doesn't really explain it. And this one. So now we're gonna get our correlations. So that's gonna be a correlation between each row. And this is gonna be a confusion matrix. Yeah, it's gonna be funny looking. But it'll make a little more sense. It's all about trying to understand your data much better. What it looks like at the most basic level, really. So it's gonna create a graph. It's gonna look a little. Well, it's gonna create a confusion matrix. It's gonna look a little crazy, but or a correlation matrix. A correlation matrix. Might take a second. Oh, steady swinging. All right, yeah, you see how it looks crazy? So it's basically, yeah, it's a correlation matrix using the heat map. So I want to say the darker the correlation, or the darker the color, the more correlation. You see this big block right there. That's probably the null values, or that could be our. Yeah. See, okay, so that's correlations. Do I have 2 big corresponding blocks like that? Yeah. It's a diagonal too, so. Okay. So this is the you see how long that took us? It took me like, it really would have taken me quicker if my computer wasn't acting up, but it took me like 25-30 minutes. And now we're in imputation techniques. And this is a really good article, man, because it goes in kind of some detail about some various techniques could be using. Now you see this mean imputation, arbitrary value imputation. Matter of fact, let me duplicate this. Is it this one? Oh no, it's this one. And I just want to see if I can do the mean imputation again like I wanted to before. Let's see. Okay. Let's see if we can imputation. Yeah. Okay, that's good. And this should be submission, not data. And this should be, bro, come on. What are we doing? See if this gonna work. No, it's not gonna work. I'm gonna split. You know what? We'll use this one because I just don't think that one's gonna work. Okay, so we got numerical values. That's the mean, median, imputation. That's that first one I was just trying to do. I think we'll be able to do it with this one though. Arbitrary value imputation, end of tail imputation. See, I don't know what all of these are, but we could definitely find out. Mode imputation, frequent category imputation, adding a missing category. That's categorical. Then you have both. You have complete case analysis. I think that's what we're gonna start with. Yep, adding a missing indicator and random sample imputation. So let's get right into it, bruh. All right, so this first one is a complete case analysis, CCA. I'm going to just read it. This is a straightforward method of handling the missing data, which directly removes the rows that have missing data. We consider only those rows where we have complete data, i.e. data is not missing. This method is also popularly known as list-wise deletion. Data is okay, so assumes that the data is missing at random already, so that's gonna be the null hypothesis. I need to leave me alone with these emails. Stop messing with me. Hold on. All right. Hey, Mike, how you doing, bro? What's going on, Universal Mike? Sorry, I'm trying to talk to you and do about 38 different things at once. How you doing? How you doing, Mike? Yeah, man. All right, so advantages. Of course, it's easy to implement. No data manipulation required. Deleted data can be informative. Exactly. You don't necessarily want to delete the data, but we're gonna be creating a training set anyway to be able to delete everything. Yeah, man. I don't know if we want to delete all the rows, but we can definitely try it out. Try it out. All right. It can lead to the deletion of a large part. Exactly. A large part of the data can create bias in the data set. Your data set might not be complicated enough if you delete stuff. And if we're going by 0, 1, basically it's 2 cases. Either it is or it's not. That could be one thing. But what if we're going for like really small values and you're looking at you don't think those values are significant? They might be. Okay, so can't create a bias. Production model will not know what to do with the missing data. Exactly. When to use. When the data is MAR, it's missing at random. Good for mixed numerical and categorical data. Missing data is not more than 5%. It's 5 to 6% of the data set. I think it is more than 5, significantly more than 5 to 6%. I think it said it was 100,000 or was it a million? It was one of them. Data doesn't contain much information and will not be biased against the data set. So let's go ahead and start with our shape. You should always have a general knowledge of your shape as well. All right, so we're not even gonna worry about this. You know what? Let's just go ahead and delete this whole thing. Let's delete that. All right. Delete that. All right. We just want our shape. You don't have to take clothes off. Sorry. Am I working with exactly the same data set? I guess I am. I didn't realize this was the same data set that I was working with. All right, now I'm going to actually find the columns that had a null value, the missing value, missing data. Now we're gonna actually use it with the mean, like we were doing before, to replace it with the mean. So we're using for loop for all the columns present data set with average null values greater than 0. So we're gonna be, yeah, we don't want any negative numbers. Now remember, well, this is the data set right here. Hold on. Alright, so it is one. Is that a million? Definitely a million. A million. And there are 81. So it's a million data samples, and there are 81 labels. Yes. Right, and now we're going to see, we're going to test for the values whose mean is greater than 0. It has to be greater than 0. All right, now we're going to implement the CCA, and we're going to verify the shape. It's going to be a new shape. We'll see what the new shape is gonna be. Yep. So we've implemented, we've gotten rid of all the missing values. So we created a new data frame called data_NA, which is going to be getting rid of all the null values in our data set. And then once we implement the CCA, we're going to drop all those values. And so now we went from 1 million to 364,774. Okay. That's a lot. Right. So now we created a new data set or data frame that's called data CCA, and data CCA is our data frame with the CCA techniques to remove the missing values. Yeah. It just said we won't use that competition. Yeah, no kidding. That's not a good way of doing things, because look how many. Think about it. I gotta get mine. Oh, reliable out. All right. So we lost a significant amount of data by removing these values. That's why this is not the technique I would use to do it, but it is a good way to kind of see how many null values there are. Now remember, the assignment is to predict what the value is going to be in these fields. So we went from 1 million. Minus 364. I just want to show what you'll be losing. All right, so 6, 3, 5, 6 out of 1 million. 63. Well, I mean, it's easy. So we lost about 64% of our data by removing the missing values. Now you're seeing why this isn't that great of a technique to just remove the values. You're reducing it down to, it's one thing if we're splitting the data set, to training and testing, but we haven't even done. We lost a lot of value, so this could be incredibly biased if we were just go by missing value. So that's not that's not going to be the final technique we're going to be using. Okay. We're definitely coming up on an hour soon. All right. So the next step is arbitrary value imputation. Now, remember, I'm saying this over and over again. I'm going to be using probably about 65% of this code, and the rest will be all mine. And the rest of the stuff that's all mine is going to be the models that I'm going to create, the algorithm I'm going to use, whatever, TensorFlow or Keras, whatever, PyTorch, blah, 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 right? But right now we're just setting it up and just kind of exploring the data. Right? So, arbitrary value imputation. What I'm going to do is we're going to see if we can get this arbitrary value imputation working, and then that'll be it for today's session. Okay, so this is an important technique used in imputation, as it can handle both the numerical and categorical variables. This technique states that we group the missing values in a column and assign them to a new value that is far away from the range of that column. Mostly we use values so they use really large numbers. So it's, what was that, 99 million? 99 million or some shit, minus 99. So it's a really, obviously our numbers aren't going to be that ridiculous, but it's a really large range, right? So they'll use that range or missing or not defined for numerical categorical variables. So it's going to fall within that range. Okay, data is not missing at random. Is the data missing at random? Well, I guess. I don't know if it is random. The missing data is imputed with an arbitrary value. That I'm sure it is random. That is arbitrary value. The missing data is imputed with an arbitrary value that is not part of the data set or mean or median mode of the data. So it's just some crazy number in between these, just so it makes it clear, like it's like night and day comparison. It's easy to implement. You can use it in production. It retains the importance of missing values if it exists, and that's what the difference is between removing the missing values and this technique, which is replacing with arbitrary numbers or comparing it to arbitrary numbers, because you're removing a significant amount of importance by removing 63% of the data set. So yeah. Okay, so the disadvantages: can distort original variable distribution, arbitrary values can create outliers, extra caution required in selecting the arbitrary value. Yeah, you really you gotta be more specific. You don't want to be minus 99 million and 99 million, because that's going to use a lot of computational power, and you want to minimize that as much as possible. So okay, when to use when data is not mar, it's suitable for all. All right, so now we're gonna create our actual training, our first training data frame. All right, it's gonna be a copy, and we're gonna have the search for NA variables. It's going to create a for loop, and it's going to search in the columns. If it is, it's going to search for the means that's greater than 0, just like it did before. Use gender column. I didn't even know there was a gender column. Define the values in the column. So there's a gender column apparently. I got to explore the data more. But this is just a column for gender. I should have known that. It says F and M. So F. I didn't realize that the F actually stood for female. All right. Using arbitrary imputation technique, we will impute missing gender with missing. Yeah, okay, so every time it says it's not there, it just says missing. You can use any other value also. Right now I'm just gonna use the female one because that's what they have, and I think that's gotta be just easiest for right now. Continue for each column. Okay, all right. Right, those are unique values, and now you can use any other value also, and let's go ahead and try it. Okay, so these are our values. We're supposed to have negative numbers. Yes, we are. All right. So you see that range is crazy though. That actually. I'm only doing this one column that's wide, so because we're using using arbitrary imputation technique, we will replace missing gender with missing. You can use any other value also. Okay, so we replace any missing value with an arbitrary missing variable, not variable. Impute missing gender with missing. It's just gonna say missing, right? So I wanna see what that looks like really quick. Okay. Let's see what some of these look like, because this is a data frame. Is it not? Yep. This is that F underscore 1 column. Yeah. they're all female then. Is that F? The F, is that what that stands for? I'm just looking at this correlation matrix right here. Seems like it's obviously there's some distortion there. There's distortion there. And that's a diagonal, right? So that's where it's most concentrated along those lines. This is one. That's just one. I could do the whole thing. We gotta hold off on doing the whole thing, though. Yeah, buddy. Okay. Yeah, that was just that first one right here. F10. The mean. Deviation. So there shouldn't be any null values, right? Because replace them all with those arbitrary values. Let's just see. I would see something by now. Yeah, so replace it with the arbitrary crazy number, crazy negative number, or crazy positive number. It just depends. That so it says missing value, just crazy number within this range. Okay, yeah. Nah, man, that's excellent. Hey, we got some progress done to Dizzy, and we did it in an hour. Around an hour. Yeah, man. Woo! Like, share, subscribe. We made some progress today. So today we basically did 2 imputation techniques that are not going to be ideal for the competition. But the first one we did was the mean variance. No, I'm sorry. Missing values and completely removing the rows. And the second one we did was replacing the missing values with arbitrary values. So just some between a range, a very large range of numbers. And you basically compare the two just arbitrary numbers. Every time there's a null value, you put just a arbitrary number just to fill it. Again, that's still not the one that you want, because you don't want to just put just this arbitrary range. You want it to be more accurate, and because it's set up for where the missing values are random, the arbitrary one and the other one is set up for when the missing values are not random, I believe. Hold on before I start sounding crazy. Okay, data is not missing at random, and our data is missing at random. So this is not going to be the great technique, but it's you get to see actually what imputation is, and that's really the assignment is imputation, but it's also predicting the values of that imputation. So it's not just replacing 0, 1, 0, 1. We actually need to predict these values, these float values, because that's what they are. Okay. So cool. You see how that sounds crazy? Like, this sounds crazy. Maybe there's some interference in the RAM or something crazy like that. But anyways, fam, thanks again. It's the Elevated Engineer. We're doing more and more type of this stuff. We appreciate all the support. And go ahead and start making something cool and drop a couple of likes or something. So with that being said, that's it.